Namaskar, my dear friends. Let us continue with probability topic. So we have started basics of probability and how to find probability, and we have seen few gate problems as well in the last session. Now we'll see more problems. So let us say the question is, this was asked in gate. If a dice is thrown twice, if a dice is thrown twice, like one dice has been tossed two times, okay? The probability that the sum is neither 8 nor 9, okay, is what? So this is the question that is there with us. What it means is, let us say if you throw a dice, what you can get, let us say first time you got 1, second time you got 3. So the sum of the digits will be how much? 3 plus 1, that is 4. Now your aim is to find the probability that this summation should never be 8 or 9. So first of all, what we will do is, we will try to find out all the sample space, like what is the possibilities, and then we will see what is the probability of getting 8 or 9, and then we will subtract that, right? So that one we can do. So you know already what is the probability of getting 8 or 9. That can be written as probability of 8 plus probability of 9, because it is a mutually exclusive event. Mutually exclusive. We will see what is mutually exclusive, because the summation can never be 8 as well as 9 together, right? So that's the reason it is exclusive, right? So why don't we do one thing? First, we will list out all the probabilities, all the possibilities that is there with us. So what is the possibility? We can have first trial 1, second is 1, then 1 2, 1 3, 1 4, 1 5, 1 6. Second trial we can do 2 1, 2 2, 2 3, 2 4, 2 5, 2 6. Like that, all others you can continue, right? And similar to that, we can have 6 5, 6 6. So you can see we have these many availabilities that is there with us. Now can you find out that which are the possibilities where you are going to get summation 8 or 9? So those possibilities are only this: 6 2 8, 5 3 8, 4 4 8, 3 5 8, and 6 2 6 8. So this one is one, and then 9 will be 6 3 9, like that, this one, okay. So you can see this is how many we have: 1 2 3 4 5, and this is 4. So 8 is 5 times and 9 is 4 times, okay. Rest all others you cannot see. So you can see we have 8, that is number of events even. Sum is, let's say, 8. So any one will be how much? 5. And sum is 9, that is NE2 will be 4, okay. So can you write it down? The probability of 8 or 9, that can be written as probability of 8, that is 5 by 36, plus probability of 9, that is 4 by 36. Why 36? Because total number of outcomes. So total number of outcomes are how many? 6 in one dice. So 6 into 6, that is 36, or 6 square. Okay. So that's the reason I am telling you that it is total 36. Okay. So if you sum this, you are going to get 5 plus 4 9, that is 9 by 36, which is going to come up as 1 by 4. Now this is the probability that is there for getting summation 8 or 9. Our aim is to find out probability which gives me the probability doesn't come either 9, I mean 8 or 9, right? So for that what we can do, my required probability will be probability of neither 8 nor 9, means 8 complement and 9 complement. So that can be written as probability of 8 or 9 complement, right? And this can be written as 1 minus probability of 8 or 9, okay? Because if 8 or 9 doesn't should not happen, so what is the probability that 8 or 9 will happen? That is 8 or 9. So it means it can be written as 1 minus 1 by 4, that is 3 by 4. So 3 by 4 is the answer for you. If you want, you can write it very easily, this one, like probability of neither 8 nor 9 will be equal to 1 minus probability of 8 or 9. That is very simple. Let us take another question. This was asked in GATE last years. So question is, I'll write the question in short. We have a box which contains 5 red ball and 7 green ball. Okay. Now a ball is drawn and color is noted. A ball is drawn and its color is noted. So like from the box you are drawing the drawing the balls 5 red and 7 green. Now you drawn one ball and you have noted the color, what color was it, right? Then put back along with another ball of the same color. Okay. Ball is put back along with another ball. Okay. Another ball of same color. Probability of getting red in the next drawn is, the probability getting red ball in the next drawn is. So our aim is to find out, let's say we have a box in which 5 red and 7 green balls are available. You are taking out one ball, let's say that is green ball. Now you are putting that one more green ball, so green ball will become 8 and inside 5 red are there, right? Next time again you are going to get one ball, right? So what is the probability that next drawn ball will be red? Okay. So how can we do that? You can take a moment and try to solve it. Or otherwise, what is the main understanding to find this is let us say our aim is either you have got, let us say getting red ball in the next draw. So what is the possibility for this? Either you would have got red ball in the first place and then again you have to get red ball, right? Or otherwise, let us say you would have got green ball in the first place and next drawn you have to get red. Got it? So how can you visualize this? let me give you a proper understanding for this case. This is very interesting case. Okay. So we have how many, tell me? Let's say we have 5 red and 7 green. What is the possibility that you will get red? So the possibility that getting red is 5 by 12 because 5 red are there and total balls are 12. Now as soon as you got this like option, then you will be having, since you have got red, you will be having 6 red and 7 green because one red ball will be added. Then what is the possibility of getting red in the next turn? So that will become 6 by 13 because 6 is the red numbers, right? And this is the next drawn of red. But the possibility can be green also in this case. So what will be the green in this case? In this case, green is going to be 7 by 13. Now let us say in the first place you got green. So what is the possibility of getting green? It will be 7 by 12. Now since 7 by 12 is the green possibility, you would have put one more green ball here. So that will be 5 red and 8 green. Now what is the possibility of getting red in the case? In this case, red will be 5 by 8 plus 5, that is 13. And in this case, what will be the green possibility? That will be 8 by 13. So this is the complete probability like tree that we have drawn, and then this one is second drawn, like next drawn you can see, right? Similar to that you can keep proceeding other. So but I have to get next drawn only, so not a problem. Now can you see from this probability and this one, so you can quickly write down what is the probability of red? 5 by 12. So I'll write down quickly 5 by 12 into, again next time red will be 6 by 13. So you have to go like this. You got red and then again red is 6 by 13. Then next one is you have to get 5 green. So probability of getting green is 7 by 12. But from 7 by 12 you have to get red. So that is 5 by 13. Okay. Now if you multiply these, then you are going to get 12 13 156, 156, right? So this is 5 into 6, that is 30, plus 7 into 5, that is 35, right? So you are going to get 65 by 156, and if you divide it by 13, what will happen? 13 pache 65 and 13 12, let it be, so it will be 5 by 12. So 5 by 12 is the answer for this particular next drawn red ball. Okay. If you do have any doubt or any understanding that is still needed, you can put down your queries in the comment box, or you can ask, guys. Let's take another question. Question is the probability that a given positive integer lying between 1 and 100 is not divisible by 2, 3 or 5. The probability that a given positive integer between 1 and 100, both included, okay, is not divisible by 2, 3 or 5. So this is the understanding that we have to have. How do we do that? Take a moment and try to solve by yourself. So you know already, like, what is the divisible decision. Let's say we have a number a, so divisible by 2, divisible by 2, b divisible by 3, and c divisible by 5. You know the rules of how a number is divisible by 2, 3 or 5. Okay. So what is the aim, or what is the understanding that we should apply is how many number of like how many numbers are there between 1 and 100 which is divisible by 2. then which is divisible by 3. That all we will try to find out. Okay, so can we do that? We can see we can see that number of numbers between 1 and n. Okay, 1 and let us say 1 and r divisible by n. N is. So how many numbers are there which is divisible by n between 1 and r? So that can be very easily found out by greatest integer function, which is going to be r by n. Okay. And you know already greatest integer function, let's say 2.3, so that will become 2, and 3.5, that will become 3. Like that you have to see. So can you tell me quickly number of integers divisible by 2? By 2. So that is going to be equal to, we have total 100 numbers, 100 by 2, that is going to give us 50. Similar to that, number of integers divisible by 3, that is going to be 100 by 3. So this is 33.33, that is going to give me 33. Similar to that, numbers divisible by 5. So that is going to be 100 by 5, which will give us 20. So we have found out all the integers which is divisible by 2, 3 and 5, right? Now to get 2 and 3 numbers divisible by 2 and 3, that will be equal to how much? 100 divided by, there are few numbers which will be divisible by 2 and 3 both, because they will be common, right? 2 has divided 50 numbers, 3 has divided 33 numbers. Out of these two, there will be numbers which will be divisible by 3 as well as 2 both. Let's say for example 30. So that's the reason it is going to be 3 to the 6. So the number which is divisible by 6 will be divisible by 2 and 3 both. So that is going to give us 16. The numbers divisible by 3 and 5, that is going to give me 100 by 3 pache 15. So 15 छक्का 90, 6. Numbers divisible by how much? 2 and 3, 3 and 5, 5 and 2. So that will be 100 by 10. So that is going to give me 10. One more remaining is how much? There will be few numbers which will be divisible by all the 3, 2, 3 and 5. 2, 3 and 5. So that is going to be 100 divided by 5 diya 15 duna 30, 30. So total 3 numbers will be divisible by that. So what is the required probability? Our aim is to find out those numbers which are not divisible by any of these. Okay. So first we'll find out which of the numbers which are divisible by all of these. Okay. So can we find out probability of A union B union C? I told you A was divisible by 2, B was divisible by 3 and C was divisible by 5. So can we write it down? Probability of A plus probability of B plus probability of C. Now what is the next case? Minus probability of A intersection B minus probability of A B intersection C minus probability of C intersection A. Then plus probability of A intersection B intersection C. So as you can see, the total probability of like PA. So PA total number was 50, right? So I have by 100, okay. So I can write it down very quickly. 50 by 100 plus B was 33 by 100 plus C is 5, okay. C was 20 by 100 minus, we have identified PA intersection B also, 16 by 100 minus 6 by 100 minus 10 by 100 and plus last one was 3 by 100. Now if you put together all, you can see we have how much? 1 by 100 I'll take common. So you just add it, 50 plus 33, 83 plus 20, that is 103 plus 306. So 106 minus 16 22 10 32. 32. So it is going to give me how much? 74 by 100. This is the probability of get a number which is divisible by 2, 3 or 5. Now what is the probability of not divisible by 2, 3, 5? That is P A not A intersection not B intersection not C. So that is going to give me 1 minus all of them, P A union B union C. 1 minus 74 by 100, that is going to be 26 by 100 or 13 by 50. So this is the required probability that you are searching for. All right, please make a note of it. Let's take another question. Question is, from a pack of regular plain cards, 2 cards are drawn at random. Okay. From a pack of regular plain cards, 2 cards are drawn at random. What is the probability that both cards will be kings if one and if card is not replaced? Okay, both cards will be kings if card is not replaced. It means, like, let us say you have drawn one card, you are not replacing, you are drawing one more card, like that it is. Okay, so options are 1 by 26, B is 1 by 52, C is 1 by 169 and D is 1 by 221. So take a moment of time and try to solve. Let's say how to solve this. Very easy. We have to find out the cards will be king both, right? Both of them has to be king. Probability both kings. So what will happen? Let's say you drawn one card. What is the probability that you will be having king? So you have total 4 cards which are king out of 52 cards, right? So we'll be having 4 by 52. This is the probability. Now second time, what will be the probability of getting king? Because one king you have drawn already, so remaining will be only 3. So 3 by 52. Okay, sorry, 3 by 51, because one card has been drawn. So if you do that, you are going to get how much? 4 एकम 4, 13 चौका 52, 17 51. So it is going to be 1 by 13 into 17, that is 17 21, 17 51, 17 एकम 17 5 22. 1 by 21. This is your answer. Okay. Why don't we do one thing? We'll have little bit concept about it. Okay. So you can see we have total 52 cards. Out of that, we have like a spade, and then we have club, and then we have heart, and we have diamond. So each of them are 13 pieces. Okay. Now the number they are having how many? 9 are numbers and 4 are face cards. Similar to that, each of them are 9 plus 4, 9 plus 4, and 9 plus 4. Okay. So basically you can see in each suit, basically like a spade suit, 9 cards are numbered from 2 to 10. Okay. And 4 cards are face card. You can see what are those face cards. They are like ace, that is A, and then we have jack or gulam it is, and then queen and king. Now let us say we want both kings. Now there is a possibility we want to find out what is the probability that two kings, number one, at a time, like both the cards drawn together at a time, what do you want? The probability of this event will be, you have total 4 cards which are king. Out of that, 2 you want immediately, divided by total 52 cards are there. Out of that, 2 cards you are drawing. Okay. So that is going to give you 1 by 221. Okay. Or if you want, you can draw it like factorial 4 divided by factorial 2 into factorial 4 minus 2 divided by factorial 52 divided by factorial 2 into factorial 52 minus 2. So if you do this, you are going to get, how do you do that? 4 into 3 divided by 2 into, yeah, 2, that's all, divided by 52 into 51 divided by 2 into, yeah, 2, that's all. So we are going to get how much? 4 tiya 12 by 2 into 2 by 52 into 51. 2 got cancelled. This is 6. No, we'll take 4. 4 3 ja 12 and 13 3 se 17. So it is 1 by 221. Now there is another possibility. One after another without replacement. Okay. One after another without replacement. So what will be the probability of this event? So that can be written as, first of all, it will be 4 by 52 because 4 kings are there. Since you are not replacing, the next attempt it will be remaining only 3 kings, divided by 51 cards will be remaining because one has been removed. So this is your probability. Another case can be another case can be with replacement. I will write it down one after other. With replacement. So what is the probability for this one? So one after another means 4 kings were there, you have 4 by 52. Since you have replaced this drawn card, again 4 will be there in the deck. So you can write down 4 by 52 2 times. So this is the total answer. Let us take another question. The question is, 4 cards are randomly selected from a pack of 52. from a pack of 52 cards. If the first two cards are kings, if the first two cards are kings, what is the probability that probability that the third card is king? Card is a king. So we have to find out what is the probability that third card will be king. Okay, options are 4 by 52, B is 2 by 50, C is 1 by 52 into 1 by 52, and D is 1 by 52 into 1 by 51 into 1 by 50. Okay, so this is the options. Let us solve it. Can you try by yourself? We have to see that first two cards are already found out, which were actually kings. What is the probability that the third one will be king? Okay, so you know probability of third card is a king. What will happen? Since two cards are already kings, so what is the remaining number of two cards? That will be only kings. So we have only two cards. Out of that, one we have to find out, and total remaining cards are actually 50. So 50C1. So this is the probability. That's all. So 2C1 divided by 50C1, that is 2 divided by factorial 50 is going to be 1 by 25 or 2 by 50 only, right? So 2 by 50 means B option. Okay. Let's take another question. The box 1 contains chips numbered. The box 1 contains chips numbered 3, 6, 9, 12 and 15. Right? Box 2 contains chips numbered 6, 11, 16, 21 and 26. Two chips, one from each box are drawn. Okay. Two chips, one from each box are drawn at random. The number on the chips are multiplied. The numbers on the chips are multiplied. What is the probability that product is an even number? The probability that the product is an even number. So can you tell me what is the probability that you will have an even number? Solution. Take a 2 minutes time and try to solve this. We have two boxes with these numbers of chips, right? So you can see, let us say we have box 1 as, let's say, 3, 6, 9, 12, 15, right? and the another box is having, let's say, 6, 11, 16, 21 and 26. Now I am going to put a tick mark for even product, like let's say 6 into 3, that is 18. So 18 is an even number, right? So I'll put tick mark and I'll put cross mark for odd product. Okay. So you know already that uh, odd into odd will be odd and rest all will be even, right? So 3 into 6, that is even. 11 into 3, that is odd, right? So even, odd, even. Similar to that, this is even, this is even, even. See, one of them is, like a even number 6, so it will all be even. This is how you can put it. Now 9, so cross tick. Then 12, all are even. And 15, tick cross and then tick cross tick. Okay. So this one I'll put it here. So you know now very easily what is the probability that my product will be even, right? This is the thing that they are asking you. So total how many combination? 5 into 5. So total 25 combinations are there. Out of that, how many tick marks are there? So you can remove the cross marks. 1, 2, 3, 4, 5, 6. So 19 are 25 minus 6, that is 19. So 19 are even. So your answer is 19 by 25. Understood? How to find that the chips numbered will be even, when multiplied that will be even number. Okay. Let us take another questions. Aishwarya studies either computer science or mathematics every day. Okay. Studies either computer science or mathematics every day. If she studies computer science on a day, on a day, then probability that she studies mathematics next day is 0.6. Then probability that she studies maths next day is 0.6. It means if she studied computer science today, next day, what is the probability that she will study maths is 0.6. If she studies mathematics on a day, if she studies mathematics on a day, then probability that she studies computer science next day. Next day is, that is 0.4. Okay. Given that Aishwarya studies computer science on Monday, given that, I'll put it C. C studies computer science on Monday. What is the probability that CA studies computer science Wednesday. So this is going to be very, interesting question. Okay. So you know already that CA studies only one subject in a day, and if CA studies computer science today, next day will be maths, that is point 0.6. If CA studies maths today, then computer science will be CA studies maths today, then computer science will be the next day is point 0.4. Now C is studying computer science on Monday, that is definite. Our aim is to find out what is the probability that C will study computer science on Wednesday. Okay. So can we do one thing? Let us say we have Monday, okay, and she has studied computer science. So we have Tuesday and we have Wednesday. Now Tuesday, she studied computer science on Monday. So Tuesday maths will be how much? Math possibility is 0.6, and uh, computer science possibility is how much? 0.4. That you know, right? Now I don't know what is the probability that computer science will be there on Wednesday or maths will be there on Wednesday. That we have to find out, because based on this we understood, right? So let's make this table. Okay, let's make this table and try to identify. Okay. So how shall we do that is let us do this way. Uh, we know that if she studied computer science on Monday, right? That is very definite. That is given. Then on Tuesday, what will be the probability that she will study maths? That is going to be 0.6. So in that case, what will be the probability that she will study computer science? That is 0.4. Okay. Now let us say if she studied zero point 0.6 maths, like, or she studied math that day, then what is the probability that she will study computer science next day? That is going to be 0.4, right? That will be your computer science. Similar to that, even if she studies computer science on Tuesday, zero point 0.4, then again computer science on Wednesday will be again 0.4 only, right? So I can write down the probability of computer science on Wednesday is going to be Tuesday. What is the probability of computer science on Tuesday? 0.4 multiplied by 0.4. Next day is computer science, right? See, our aim is to find out probability that Wednesday is computer science. So first we are starting from Tuesday. Tuesday 0.4 is computer science. Next day computer science will be again 0.4 plus, let's say Tuesday she studied maths. Then what will happen? 0.6. But computer science must be on Wednesday. That is 0.4. So this is the required probability, which is going to be 4 चौका 16 plus 6 चौका 24. So that is 0.4. Understood? So all right, keep up to this. Next we'll start with conditional test or conditional events, and we will have a lot of questions based on that conditional events, because that is going to be very interesting topic. Or why don't we do one thing? Let us see the theory of conditional events, and then we'll see like questions next. So let us start. Conditional events. So in conditional events probability, what do we do is we write like this, A by B. It means A given that B. It means what is the probability of A given that B has already happened. Okay, B already happened. B already understood. Or if you write B by A, what does it mean? B given that A. It means A already happened. Got it? So the probability of A by B is nothing but probability of A intersection B divided by probability of B. Similar to that, probability of B by A is going to be probability of A intersection B. See, probability of A intersection B or B intersection A, both are same because A intersection B is commutative. Okay, divided by probability of A. Okay. So let's take an example. Question is, a coin tossed three times. Three times. So what is the sample space that you guys know already? What is that? Head, 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 tail, head, tail, head, and tail, head, head. Then tail, head, tail, 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 head, and how many are there? Seven, right? Then we have head, tail, tail, and then tail, tail, tail. Got it? Now let us say the events are A getting two heads, getting two heads, and B is first coin results head. Okay, so our aim is to find out what is the probability of A given that B. Okay, like probability that first coin is already happened, that is head, and we have to get second coin will be, I mean two heads we will get it. Okay, that's the question. Okay, so you know what is the probability that we are going to get first coin as head? Probability of B. So you just see where first times head has happened. 1, 2, 3, 4. 4 times head has happened. So 4 by 8, that is 1 by 2. Now, what is the probability of what is the intersection of A and B? A and B both. So A and B both, you can see we have two heads, right? So first of all we need to find out when my A is happening. So we need to get two heads. It means even if it is this one, this one, and this one, these three are there, which is giving you two heads, right? So you can say in all these three, how many options are there which is having A B available? So that is first two. So you have A intersection B as H H T and H T H. So can you now tell me probability of A intersection B will be 2 by 8, that is going to be 1 by 4. So my probability of A by B is going to be probability of A intersection B divided by probability of B which is already happened. So that is going to be 1 by 4 divided by 1 by 2. So that is going to give me 2 by 4, that is 1 by 2. So hope you understood hope you understood that what is the probability of B getting first coin as head, which is 4 numbers, right? Then What is the probability that A and B both will happen? That is two numbers of a head will happen together. So that will be these two. So what is the probability that A will happen given that B is going to happen? That will be A intersection B by PB. Okay. Now let us say you want to do like this. You want to find out probability of A intersection B. So that can be written as very easily probability of A into probability of A by B, or it can also be written as, or I can write it down equal to probability of B into probability of A by B. Sorry, B by A. What was that? We have probability of A by B is probability of A intersection B by PB. Okay. So I will write it down here as B by A. And then here probability of B into probability of A by B. Okay. Because you know already that probability of A by B is nothing but probability of A intersection B divided by probability of B. Similar to that, probability of B by A is probability of A intersection B divided by PA, right? So this is called as multiplication theorem on probability. On probability. Got it? Now let us talk about independent events. Why I am telling you independent events here is because you are telling that something has already happened. What is the probability that other thing will happen? Because you are thinking that something has already happened means my next thing is going to depend on that. What if it is not depending on that? Whatever has happened, let it happen. I don't care. Understood? So if you do not care about that, or it is not affecting your next event, it means the next event is independent. You are not actually going to get affected, right? Whatever has happened, let it happen. So in that case, you can say that two events are said to be independent if the happening or non-happening of one event happening or non-happening of one event is not affected by other event. Affected by other event. Okay. So next one you can say, let's say A is said to be independent of B. A is said to be independent of event B if, when it will be said, let's say I am telling you that event A is not getting affected by event B. When it will happen? When I will tell probability of A by B, like probability of A given B is there, is still equal to probability of A. Okay. Similar to that, B is said to be independent of A. B is said to be independent of A if my probability of B given A is still equal to probability of B. Okay. So you can tell that A and B are independent if and only if my probability of A intersection B is going to be equal to probability of A into probability of B. Okay. means they are independent. So if they are independent, this is very important relation, like probability of A intersection B will be equal to probability of A into probability of B. Next is, if A and B are independent, then our aim is to like have these relations very handy. My A complement and B are also independent. Okay, B is A and B complement are also independent, and C is A complement and B complement are also independent. Okay. Next is A, B and C are said to be independent. Three events I am including now. Said to be independent if, so if there are three events, what we can do is, if A is probability of A intersection B is equal to you know already probability of A into probability of B, then B is probability of B intersection C will be probability of B into probability of C, and then probability of A intersection C will be probability of A into probability of C, and probability of A intersection B intersection C, that is going to be equal to probability of A into probability of B into probability of C. So with these relations, you are going to find out, lot of questions have been asked in GATE in last years. Okay, so I'll give you a simple question now, and then we'll start with independent event probability problems next session. So we have a question that probability of X is given as 1 by 4 and probability of Y is given as 1 by 3. Okay, we have to find out that X and Y are independent, then probability of X given probability of Y, probability of event Y given X is what? Okay, so what is given is, we probability of X and probability of Y is given, and it is also told that X and Y are independent. Then probability of Y given X is what? Okay, so what is the solution for this? You can tell very easily that we have probability of X is given 1 by 4, probability of Y is given 1 by 3. What will be the probability of X intersection Y? Since both are independent, so I can write it down, probability of X into probability of Y, right? So that is going to be 1 by 4 into 1 by 3, that is 1 by 12. Now probability of Y given X will be what? Probability of X intersection Y divided by probability of X, right? And X intersection Y is nothing but what? It is probability of X into probability of Y, right? Probability of X into probability of Y divided by probability of X. So it is nothing but probability of Y only, which is going to be just 1 by 3. So you don't have to calculate anything. It's very easy, very simple. What was that? Probability of X is given, Y is given, both are independent. Then what is the probability of Y given X is nothing but probability of Y itself. Okay. Alright guys.